Thank you very much, everybody, for being here. I'm really excited to be at this conference this weekend, and thank you very much, Ted, for inviting me to speak in this session. And yeah, there's going to be more thanks later, but I am here to tell you about a really exciting, wonderful experience I had this past semester teaching Calc 3, using, for the first time, a really actually inquiry-based modified Moore method, whatever you want to call it, and it was totally awesome. So some bit of background, I teach at the US Naval Academy, which is different from most other institutions in at least some way. It is a public liberal arts engineering school with about 4,000 students. It's very important to the institution that the students graduate on time in 4 years. And they are all, sometimes we say we hire all of our graduates. They are commissioned as either an ensign in the US Navy, or about a quarter of them go Marine Corps, and then as an officer in the Marine Corps, and we have a handful of, like, Army, Air Force, whatever, but that's basically it. Here is one of my class from a few years ago, but this is what you would look like if you were standing in front of what you would see if you were standing in front of one of my classes. They're all wearing uniforms. The thing I said, it's an engineering school. Everybody graduates with a Bachelor of Science. They're all getting engineering degrees, even the English majors and the history majors. They all take 4 semesters of math, a year of chemistry, a year of physics, a bunch of engineering. So we have all of our students are going to be taking Calc 1, 2, 3, and then a 4th math class. Our class sizes are limited to 22, 24 students. So that's that. Plebes, that's our word for first-year students. They take 18 credit hours, which when I was a student, that was a pretty heavy load considered. And plus, everyone's involved in a sport, plus they have military training, so they're very busy people. And I said something else about the math department there, which is not very important, and I don't want to take up too much time. I wanted to talk a little bit about my history with IBL. I first heard about it because I was a Project Next fellow, and I found my letter that they sent me when I got accepted as a Project Next fellow, that I was designated as an R.L. Moore Project Next fellow, and I was funded by the Educational Advancement Foundation. So I will take this opportunity again to thank Project Next, MAA, and the Educational Advancement Foundation for introducing me to this method of teaching, which brings such joy to my life. And to answer Ted's question from before, I first met Ted Behavior in that context. And I don't remember which Project Next workshop it was, but I met Carol Schumacher. I know my first year as a Project Next fellow, and she's been very influential. And Ted gave a talk about this discovery learning, and I was just blown away by it. And I was like, yeah, that's what I want to do. So, so this is hopefully going to be brief also. I tried various ways, but I didn't have, for the classes that I was assigned to teach, I had a lot of trouble getting good notes for. And then when I was teaching the Introduction to Proofs class, which at my institution is called the Fundamentals of Mathematics, or we call it Fun Math, I gather that was actually ironic. That used to be actually ironic, but I take it seriously. It's fun math. Yeah, so fun math. And the first time I was assigned to teach it, for logistical reasons, I couldn't use Carol Schumacher's wonderful book, which I wanted to. But anyway, instead I developed this Gaussian integers unit that we could use as part of it. But again, this is me with no experience being in an IBL class and very little experience, like me sort of trying to do it as a teacher, me coming up with a problem set was not great. It was fine, but it was, anyway. The real turning point for me was in 2008 when I first came to this conference, and there was a new users workshop that Ed Parker led, and then I got paired with him as a mentor. And he gave me his problem set for his proofs class. I visited his class, he visited my class. We both kept a class diary and were in constant contact with each other, and it was awesome. It was totally, totally great. I put here 2 unhappy students. I had one who was like really, really unhappy. And he, at the end of the semester, I didn't even realize how unhappy he was, but at the end of the semester, he typed up like 1.5-page single-spaced diatribe, including a letter, I mean, essentially to the department chair saying, please, please, please do not ever let her teach this class again. He was really unhappy. The next year I taught the class again, and and that year everybody was happy. So yes, I was very lucky to have the support of my chair in that instance. One of the things, and I'll talk about that later. Okay, so this is all about what's happened before, and you want to hear about my calculus class this semester. Okay, and more background about calculus in general at the Naval Academy. So we have a lot of students, we have small classes, therefore we have, and everybody has to take Calc 3. We have lots of sections. I was one of 12 instructors, there were 18 sections. The class meets 4 days a week for 15 weeks. There's a course coordinator who writes up a syllabus, and the syllabus is like, okay, on this day you're going to do section 14.6, and here are the homework problems for section 14.6. The course coordinator programs those into WebAssign, and we all get the WebAssign assignments. There is a pretty strong tradition, though, of people saying, well, yes, the course coordinator, the experienced instructors saying, yes, the course coordinator has given me this syllabus, but I'm going to do something different. I'm going to do chapter 6 first and then chapter 5 or however. So, but some of the instructors at my institution don't feel as comfortable doing that, but I usually do. And there's a common final exam. There are 20 machine-graded multiple-choice questions that that the grades on those are posted on a drive that we all have access to. So all of my colleagues are going to know, how did my students do on those multiple-choice questions? And that's the sort of social enforcer of how, that you should stick with what everybody else is doing. And then there's also 10 long answer problems that we each grade our own long answer problems. And so that's a place where you can also and different people feel differently about whether you should or should not do this, but you can say, okay, instead of doing problem 25 that is printed here, do this problem 25 that I'm going to give you instead. So you can do that. I didn't in this case, but you can. Oh yeah, and then there are 3 proofs. I'm not going to talk about the proofs. Ask me about the proofs later. Okay. And this is some of the things that I've done before. This is sort of the base model is what I used to do. And this is probably, Ed, this is probably the time when you sat in on my class before. This is probably what you saw, is I would lecture on the new material. It's an interactive lecture. I would ask questions and get people to contribute. But it was a lecture, and then I would say, okay, and now here's an example. How would you do this problem? And they would all sit at their desks. They would do the problem. It wasn't awful. It was fine. It was okay. But it was not, I don't know. I felt like it was superficial. Fall of 2011, I tried doing a flipped classroom thing where I would ask the students to read the book outside of class, and then I would bring them in and they would work in groups on the problems. They didn't like that, and the pushback was enough that eventually I was like, okay, fine, I'll lecture. We went back to the other thing. Last spring, I tried doing, okay, how about once a week we'll have a problem day, and so Thursday was problem day, and I would write up a list of, I have 25 students, I'm going to write up 25 problems, and each student is going to pick a problem. They would go, luckily we have a room with boards all around, and they would go all around the room and write their problems on the board, and then we would try to get through explanations of 25 problems in half of a 50-minute class period, and they would go really quick. And I thought that the problem days were great, but the students didn't really find them very valuable. And they were kind, they humored me, but they did, and even in the evaluations they said, and I could tell that for some of them they were really not learning anything on those days. They were sitting and waiting for everybody else to finish writing. They were waiting for their turn to present. They weren't really paying attention to the other people. It wasn't doing what I wanted it to be doing. So, okay, but this spring I got to do the real thing. And so what I did this spring, almost all of class time was spent with students presenting their work at the board. They were allowed to consult outside resources. They have a textbook, that they used from their previous semesters, and they are allowed to look at that. They're allowed to talk to each other. I was pretty careful, though, I tried to be cagey about when they would say, well, what section of the book are we on? And I'd be like, well, we're kind of doing stuff from different sections. So I wasn't encouraging them to use the book. We were doing, somewhat different notation and stuff. Okay, let me find, I can show you the video. I have a video. Tell you a second what's happening. He's just done a complicated line integral problem where you have to integrate this vector field around a rectangle, and the problem says to integrate around the rectangle counterclockwise, and he didn't. He did it that way, and he did it up and to the right on all of them. And you know, that's one of the things that happened here. But anyway, so that's what he has just done.
So,
okay.
Here's the hard part. 4, 8, 16. It's going to be 32 altogether.
Why do you use 1, 0 to 1 for all your boundaries? Why not 0 to 2, 4?
So like I was showing over there, like, so,
Slight problem.
what's that?
You're supposed to go counterclockwise.
Oh, really?
So when you follow the path, your 2 8s will up a -8 and an 8 cancel on the path. Negative 4 and 4 cancel if you're going.
Do you want me to correct that right now, or do you want me to redo it?
So let me just interpret what's happening here is that the first question that got asked that you can barely hear even when you really have the audio there is that there's a student in the front who asked, who was asking about the parametrization. Where did you get that equation for parametrizing your line segment? And he started to go and explain that, and then somebody else came in and said, you got a problem here, because you didn't go around counterclockwise. And so now he's asking me, do you want me to go back and fix that now? And you know, I and the student who was correcting him are agreeing, yeah, it's not going to be tough to, you know, you just went backwards, you just have to flip the things on your integral sign. So he's going to do that. Let me see what else is going to happen.
Yeah.
It should be from like, the 0 to t one should be from 1 to 0. And then
0 to 2.
So now they're helping him fix it.
2 1 should be from 1 to 0 as well.
Does everybody follow why we're doing that?
Yeah.
Right, so I just asked, can everybody follow why we're doing this change? And a bunch of students are like, no. And so now he's explaining why it is that we're changing it.
I almost did. So you need to change this one. And you need to change this one. So like he said, it doesn't matter. Still the same parametric equation, can model it, but for this one, it feels so weird writing.
Yeah, so he said it's still the same parametric equation, but now he wrote t is an element of, and then square bracket 1 comma 0, close square bracket. And then he said, I feel weird writing that, which I love, you know, like it's great. And then the last thing he says at the end, he says, I can't remember now what he says, but then the last thing he says is, I just figured that out myself, which I just think really encapsulates why, you know, one of the many things that I loved about this is that as he's at the board doing this stuff, he's figuring stuff out and he's aware that that's what's happening. So anyway, it was great. Okay, so yeah, so these are some of the things that the students said. It's more interesting and more fun. I never had trouble staying awake. It was neat being pushed out of my comfort zone and was really interesting. I didn't really like it at first, but I do feel like I learned a lot on my own. Forcing us to understand problems enough to present them helped to learn the topic. And then this was the one student, again, this semester I have one student who was pretty unhappy. Drop this system, teach the class normally. This may not promote the theory of problem solving, but we have enough problems to solve and inquire about outside of class. There are a bunch of students who said that it was really time consuming and that they felt that that was a problem, and they specifically felt like it was a problem at the Naval Academy because they have so much on their plates that they couldn't devote the time that they wanted to devote to it. So that's, you know, that's a fair thing. I asked them some questions at the end, and one of the questions, how do you think this style of running the class affected your learning? I had 16 students, 10 of them said it affected their learning positively. 2 said negatively, and 4 were sort of somewhere in between. If you had the choice next semester between an inquiry-based section and a non-inquiry-based section, which would you choose? And that was pretty evenly split. Half of them would choose IBL, 6 would choose not IBL, and then some of the reasons why some of the people were kind of in the middle. How often did you get help outside of class? This is something I was really curious about, because they were doing great things in class. And I knew of at least one instance pretty early on in the semester where somebody had figured out what to do by going to a tutor. And so I wanted to know, to what extent are you doing that? And I was very pleased to find out that really they weren't much. They were pretty much figuring it all out on their own, and I was really excited about that. I used the problem set from Ted Behavior, and one of the things that I learned, oh no, all right, I'm done. I am out of time. One of the things I learned, I am not Ted Behavior. I don't go as fast as he does. I started with stuff that wasn't necessary for me to cover. So if you're going to do this and you're going to borrow somebody else's problem set, start with stuff that you definitely need to do. That's one caveat. I put a bunch of stuff here about my particular grading system. So if anybody's interested in finding out more about that, I'm happy to tell you about it. That's one of my students. And then I have some things to say about selling the method. One of the things, I'll just quickly say that I think one of the big positive things about it was that students were always earning points. I was never taking points off for anything. Everything was good. And that really helped the tone of the class a lot. So that's it. I had a lot of fun. So thank you.
So it looked like she found the best way to teach for her the same way I prove theorems. You try everything that doesn't work, and when you run out of things that doesn't work, you have a proof.
That's how we prove theorems too.
I'm wondering if you have any sense, comparing this semester to previous semesters, of the percentage of students who used the math lab heavily and that kind of thing. Like, was this an unusual amount of students using the math lab heavily, or less than usual, or?
I think it was about the same as usual, maybe less, because I know one student said they have these extra help classes that you can sign up for that meet once a week, but because we weren't following the syllabus, she went to one of these extra help classes and figured out it wasn't going to help her. So maybe less than usual even, so.
Back at the student comments section, there was like at the top part, there's this, many students commented that, it takes a lot of time. So what's behind that? Why is there this, it takes a lot of time comment, do you think?
That was their perception. I mean, and this is in the spring. These are plebes, so it's their first year. They've had one semester already of calculus at the Naval Academy, not an IBL course, because I'm the only one who would do this. So they have expectations about how much time they're going to be spending on their homework outside of class. And this took more time than that.
If you looked at the problems in the notes and the minimal guidance that's given, my students go to the math lab and then go, well, they can't help me because none of them can work the problems. It takes a lot of time to work problems that are hard.
Yeah.
Thanks. So this is a reply rather than a comment about why it takes more time. My experience, or my impression is that to learn math properly really takes a lot of time. And in a traditional course, students do not put a lot of time and do not learn math. And an IBL structure forces them to put that amount of time, which is not too much and is not unreasonable. It's just the amount of time they should be put in anyway. And the perception is that that is too much because it's more than they put in other courses in which they didn't learn. But it's not actually that they put in too much time.
Would you consider doing IBL for a Calculus 2 class?
Oh, yeah. At this point, I am never going to teach any class not IBL ever again. I'm saying that in public now here, and 10 years from now, you can be like, but yes.
Yeah. So we were chatting at the round table earlier, and what would you do if, because you have to finish so much material. Would that be a worry, given this experience?
No, I am no longer worried about that. That was one of the things that this experience, I was ready to not cover everything and get in trouble for it. I took that risk, but, and because I made a poor choice at the beginning of the semester, which is that I used Ted's notes, they start earlier than our course starts. It starts with vectors and lines and planes, but we have those pushed into Calc 2 to make more room in Calc 3 for stuff. And if I had started where I should have started, then I would have had no problem finishing everything. And so I'm fairly confident that if I take Ted's Calc 2 notes, and this time I'm going to be a lot more careful about, making sure that I've got in there exactly the stuff I need to get in there, then yeah, I'm pretty confident that I could do it. So.
I don't think I have any doubt that your students learned more. Was that reflected in the common final?
It was
Or-
not. It was
okay.
not. And so my students did worse on the common final exam. There were, on most of the questions, they did comparably to the other classes, but there were a couple of particular individual topics like find the center of mass of blah, blah, blah. We did not go over how to find the center of mass particularly.
That was in the Calculus 2 notes.
Yeah. I think it was one of the things that when I got to the end and I realized that I was running out of time, that was one of the things that I jettisoned as being like, if we don't cover this, nobody's going to die. So there were some questions like that were stuff that we generally had not covered, and so my students didn't do that well. I was hoping that in the long answer questions, there would be something that I could take and say, okay, here I can say that their writing or their understanding or their graphing or something is clearly better than my students from last spring, right? But none of the questions, it turned out, they weren't comparable enough that I could even do that. So, yeah.
I'll make one caveat there. When you teach students to think deeply about problems, they don't do as well on rote tests.
Yeah, they got to do 30 problems in 3 hours. They have to do them quick. And
Let's thank our speaker one more time.
thank you very much.